Pkl is Q killer, and another one is Pkl is JSON and YAML killer. Those are two sentences I heard lately. The former could be the case, while the latter is just silly. Let me explain. It all started with a question I got a while ago. Is Pkl Q killer? I love Q. I love it. I use it for all my complex manifests, so naturally I had to take a look at it. I tried it and I discarded it. It looked silly. However, since it comes from Apple, this Apple, I gave it another try and it still looked silly, at least when compared to Q. Still, I did not give up. I tried it for the third time and something clicked. There's something compelling about it. It started growing on me, so I decided to start using it seriously. I moved a few manifests to Pkl. Now, you might say a few manifests is not much, but it is, considering that the few manifests I chose to move to Pkl are around 2000 lines long. It is a decently big sample with quite a few repetitions, loops, and conditionals, and what's not. Hence, I believe I have a good sample for the initial judgment. Let's start with use cases. There are two primary reasons you might want to adopt Pkl. You might use it as the configuration format inside your applications. Instead of reading YAML, JSON properties, or any other format, our applications might be reading Pkl. I believe that's the primary motivation behind Pkl, and at the same time, something I have zero interest in adopting. Nothing. Nada. YAML works fairly well for that. It's easy to read from your code or from anywhere else. There is no format easier to read than YAML, and it is the de facto standard. I have no intention changing that. Now, and this is important, the fact that YAML is easy to read does not mean that it is easy to write, or to be more precise, to maintain. Anyone can write YAML, and I believe that everyone should write YAML, but in some cases, YAML becomes too convoluted when working with big or complex definitions, and when we need to update those same definitions. That's why many of us are generating rather than writing YAML. That's why we see wide adoption of Helm, Customize, JSON, Carvel, YTT, and other tools and formats, including my favorite, Q. We write templates or overlays which produce YAML, which in turn is consumed by humans or machines. That's where Pkl comes in. It aims to be a replacement for your favorite tool to generate static configurations. No matter what the format of that configuration is, it formats into YAML, JSON, JSONet, PCF, properties, plist, text proto, XML, I think, as well. There's something else. Yes, it formats into its own format. Hence, we can use Pkl to write dynamic templates that can be converted into almost any static format. That's not much different from Q. Both are special formats that allow us to define data dynamically. One, Q, is based on Go, while the other, Pkl, seems to have taken inspiration from Java and Groovy. At least that's the impression I got. Now, let's take a closer look at it. Here's one of my Pkl definitions. That's a real-world example of Pkl. That's one of the Pkl definitions I use to generate some of my crossplane compositions. We will take a closer look at it in a moment. For now, let's see what it produces. We can evaluate that file and the output is still Pkl, except that now templates were converted into the final output. Now, that won't be useful to majority of us. Unless you plan to rewrite your applications to use Pkl format directly, you expect something else. You might, for example, need to format it to YAML. All we have to do to get YAML is to add the -- format argument. And there we go. I got YAML I needed. Your needs might be different. You might need JSON instead. So let's change the value of the format argument, hit the enter key, and the output is JSON. Pkl also supports JSONet, PCF, properties, plist, test, proto, and XML. That's one of the similarities with Q. Both provide a way to define templates that represent data, and data can be output into any data format. Now, let's get back to the Pkl file we saw earlier and comment on a few of the key features. I want you to see some of the special things, not all, some of the special things Pkl does. Those few lines look very similar to YAML, except that we are using equal signs instead of colons to separate keys from values. The next few lines look more like JSON, which is normal since Pkl is, I believe, built on top of Java, which also likes curly braces. So far, there is nothing truly interesting in what I marked. So let's go up near the top where I defined a few classes. Now, if you check the documentation, you will not find information what classes are and what they are used for. The explanation starts with classes are arranged in a single inheritance hierarchy. Great! Now I know how they are arranged without knowing what they are. Well done, well done. As a matter of fact, you won't find much information about anything in Pkl docs. If there would be a competition for the worst docs ever, Pkl would be a finalist. It would not win the worst documentation ever award, since Nix would get the gold medal. So Pkl would need to satisfy itself with silver or bronze or something like that. Anyways, from what I gathered, Pkl classes are similar to Java classes. We can use them to create instances of something, and that something in case of Pkl are data objects. So here I have a class called subnet, which contains a combination of static data plus a few variables. The reason for the existence of that specific class is to avoid repetition. I had to define 3 subnets, which are mostly the same except for the zone and CIDR blocks. So I defined those 2 as variables, zone var and CIDR block var. Both are string variables without default values, meaning that whomever uses the class needs to specify them. Since by default Pkl outputs all data and it treats variables as data, I had to specify that those variables are hidden, not output. So they will not be output by themselves. Later on, I use those variables to customize the output, like in the case of base metadata labels zone key that contains a combination of static text and value of the zone var variable. Further down, I'm invoking that class, subnet, 3 times, each with different values for the zone and the CIDR block. As a result, I'm getting 3 subnets without unnecessary duplication. Everything I've shown so far are key value examples, and it took me a while to understand how to create lists. As a matter of fact, they are easy, but only once you get over the hurdle of incomprehensible documentation. If a value is a new object, it automatically becomes an item in a list. Here, for example, I'm saying that the first item in the list of resources is whatever is inside the new object. And here's a nice feature though. We can define default values of objects in a list. In this case, I'm specifying that the default API version will be abound.io beta v1, and that the base spec provider region will be by default US East 1, and so on and so forth. Later on, inside the new objects, I can overwrite specific default entries. There are also templates like the one I defined in Go template Pkl. That's a template similar to a class, yet slightly different, and I dare you to understand the differences from the docs. Anyways, over here, I'm defining some hidden variables and some data just as I did before. The major difference is that it is specified in a separate file, which I can reference as I did in the upper components Pkl. This is also a template which imports the previous template. Now, by default, templates are immutable, meaning you cannot change them unless we choose to amend them, just as I'm doing right here. By the way, you can safely ignore the insanity I have here with the value of template var set to Go template inside Pkl. The reasons for that are irrelevant for this story. So don't ask me, at least not right now, why am I putting Go templates into Pkl. Separate story. There are many other aspects of Pkl, and here's an important note. Pkl can output results into many different formats, but, and this is a big but, that does not mean that everything works in all the formats. If, for example, you go through the quick start, you will find this example. Try to output it as YAML or JSON, and you will see that it does not work. The only format Pkl can output to is Pkl, at least in the case of that example. For everything else, you need to ensure that what you're doing is compatible with YAML, JSON, JSONnet, or whatever the destination format is. And that can be frustrating because Pkl does not tell you while you're writing it whether it will work or not, really, for a specific format. What else? Oh yeah, it works as a Gradle plugin, and it supports IntelliJ, VS Code, and NeoVim. I tend to use VS Code, and the plugin is passable. It's okay, more or less, but not really great. It's not great, it works. And that's probably what matters. Don't go crazy about it. It won't be one of the best plugins ever. There are also language bindings for Java, Kotlin, Swift, and Go, which can be useful if you do choose to adopt Pkl as the configuration format instead of a tool that converts templates into something else, like YAML or JSON. I'm not sure that the former makes sense, using Pkl directly, and if it doesn't, the bindings are more or less useless. Still, you might go all in on Pkl, and if you do, and if you happen to be a Java or Go shop, you will find those bindings useful, probably. Now, let's talk about Pkl good things and bad things, pros and cons. Here's the big question. Should you adopt Pkl and ditch whatever you're using right now? The answer to that question is, it depends. And I know, I hate those answers as well, but it really depends. If, for example, you're planning to create YAML that represents Kubernetes resources, you might want to go with something specifically designed to work with Kubernetes. If it's a set of relatively simple manifests that require small amount of changes, and that's what you typically have with your own applications, Kustomize is still a better choice. If you're using third-party applications, Helm is inevitable. If you're distributing your applications to others, Helm is still inevitable, since that's what others are expecting. Should you then adopt Pkl as the configuration format your applications use directly instead of property files or YAML or whatever you're using today? Well, there's probably no need to switch, especially not this early while Pkl is still in early stages. So, does that mean that there is no space for Pkl? I think there is a good use case when the end result, YAML, JSON, XML, or whatever you're using, is sufficiently big with enough repetitions and with frequent updates. That is the situation I'm in with the crossplane compositions I shown in this video. There's around 2000 lines of YAML to be generated. It's too much YAML for me to manage directly with too many repetitions across different compositions. I have all that complexity in form of crossplane compositions precisely so that users of my services, in this case databases, do not need to deal with it. They will just create a few lines of YAML that represent claims, and all the required resources will be assembled inside the control plane cluster. Nevertheless, I need to assemble all that YAML somehow, and writing YAML directly is not an option, so I needed something else. That something else could be Helm charts, which I don't like. Helm is unaware that it is working with data. It is a free text templating engine. On top of that, it's missing too many features I deem important. Hence, Helm is not a good option, at least not for me. Then there are formats like JSON, YTT, and a few others which do not make sense for simple setups, but are great, absolutely great for situations I am in. However, my choice is none of those. I prefer Q backed by Timoni. By the way, if you're not familiar with Q or Timoni, please watch those videos over there. So, in my case, if I'm to adopt Pkl, it would be as a replacement for Q, which I use to generate YAML. Hence, the initial two questions are good ones. Should Pkl replace JSON or YAML? The answer to that one is a big no. Big no. If what you have is small enough and does not update frequently, use YAML or JSON directly. There is no need to complicate your life with anything else. If your situation is more complicated and you need to generate YAML or JSON, then the question is a different one. Should Pkl replace JSONnet or Q or whichever other solution you might be using? I'm now torn between Q and Pkl. I feel that Q is a better choice, but with a steeper learning curve. If you master Q and you learn to deal with its immutability, you should probably stick with it. On the other hand, if you want something easier to learn, yet very, very effective, Pkl is actually a pretty good one. Nevertheless, it will still take a while until you wrap your head around it. You won't learn it in an hour. So it's somewhere between the simplicity of Kustomize on one hand and Q or JSONnet on the other. Personally, I stopped using anything but Kustomize for simple situations and Q for more complex scenarios. Now I'm adding Pkl to the mix, and I will do my best to continue using Q for some of my projects and Pkl for others, so that I can get a better understanding of the pros and cons of both, and more importantly, figure out which one feels better. After all, if both can accomplish more or less the same results, it's more about the feeling than anything else. Hence, I will use both in the upcoming months and try to establish which one of the two I like more. With all that in mind, here are the pros and cons, but Unlike in other videos, they are heavily focused on my use case. Starting with negatives or cons, the first one on the list is documentation. It's not the worst documentation as so, that privilege goes to Nix, but it is still pretty bad. Pkl is a language or a DSL, making it hard to figure out what is what without a good documentation. If it would be yet another tool, the story would be different. It's relatively easy to understand what a CLI does or what to do in a web UI type of solutions, but this is not it. This is a language, and a language needs exceptional documentation and plenty of examples. Moreover, it's not only about the docs alone. For example, given that Pkl is relatively new, you will not find much help outside the official docs. You cannot rely much on Stack Overflow, and AI tools like Copilot will not help you either. As a matter of fact, I asked GitHub Copilot to explain a Pkl file, and it deduced that it is HCL or something similar. All that is to be expected, and it's a phase that any new project, especially a language, needs to pass through. If Pkl gets wider adoption, it will have more contributions, including the docs, it will have conversations on Stack Overflow and Reddit, and AIs will eventually learn what it is. But that is the future. That's not the stage of the project today. The second negative point is a single word question. Why? What is the reason behind the existence of yet another language or a DSL that allows us to transform data into YAML, JSON, XML, or any other static format? My understanding is that Apple uses it internally. It probably works well for them, so there is a strong chance that it will work for others. And that's great. I will always support companies sharing their internal projects. There is even a page in the docs that compares Pkl with other solutions. It talks about the reasons why not to use a static config format like YAML, JSON, and XML, and that makes sense. That's why we have languages like Q, templates like Helm, overlaying solutions like Customize, and other config languages like JSONnet and HCL. There was no reason to compare itself with static config formats. That's obvious. Then it goes into a comparison with general purpose languages, and that makes sense as well. Most of us do not use Python or Java or JavaScript to create static configs. We have tools for that. We have Q, which is based on Go, Helm, which is also based on Go, CDKs, which works with almost any language, and many others. Hence, I understand why we should not use general purpose languages directly. The disappointing part is that the docs did not mention any of the libraries and frameworks that are based on general purpose languages. That would be a good comparison. Even if you would say that Q and Helm are not good because they use Go syntax, which you might not like, and CDKs is too much focused on Kubernetes, there is still Pulumi and many others that can transform your general purpose language of choice into YAML or whichever other format you need. I suspect that the key is in Java. I suspect that Pkl creators work with Java and wanted something close to Java, yet something that is not Java alone. Finally, the comparison page goes on to compare it with configuration languages like JSONnet, HCL, and DAL. There are no good arguments in the documentation over there except embedding into JVM applications, making my suspicions that it's all about Java valid ones. All in all, I'm not sure that the reasons for creating Pkl are valid beyond the ability to embed it into JVM applications. Yet, it's here and we can use it. Finally, the last negative point is that it is not better than Q. At best, it is slightly easier to learn than Q, especially if you're not familiar with JSONnet and Go, since Q is a combination of those two. Where Pkl shines is for those not familiar with those languages. It takes time to learn Pkl, but it probably takes even more time to learn Q, so I will change my statement to Q is probably a better choice for complex setups if you're willing to learn it. Those are negative points that might make you think that I really dislike Pkl, but that's not the case. The more I use it, the more I like it. I'm not saying that it will replace my configurations defined as Q, but only that it could. It might. Time will tell. As for the positive points, for the pros, to begin with, Pkl is relatively easy to learn when compared to JSONnet, Q, and other languages and formats. It's not easy though. It's not easy. It's just slightly easier, and that's a good thing if the goal is to get wide adoption. Another great thing, even though it is not unique, is that we can output Pkl to almost any static configuration format. If you need the YAML, it can be output to YAML. If you need JSON, it can be output to JSON, XML, properties, PCF, all are supported. Now, to be clear, that's not much of an advantage since Q and others can also output to almost any format. When the purpose of a language is to generate structured data, it is easy to output that data to any format. Still, Pkl can output to almost anything, and that's a good thing, even though I doubt that you will need the same data in more than one format. The last potentially great feature are language bindings. If you want to consume Pkl format directly from inside the code of your application, Pkl allows you to do that easily, as long as that language is Java, Kotlin, Swift, or Go. Whether you should do that, whether you should have your app consume Pkl files instead of YAML, JSON, or XML is a completely other question. I would say no, but I might be wrong. So I'm giving language bindings thumbs up just in case I'm wrong. All in all, Pkl is growing up on me. It started with, I don't like this, I don't understand why it exists, and now it is in the, it might be a good thing type of category. I will continue using Q for some of my projects and Pkl for others. I will let you know which one will prevail. Thank you for watching. See you in the next one. Cheers.